Hello, my name is Tarek, and in today's lecture we will examine the code and we will do some analysis on that, and we will see how can we measure the complexity of that code. So now let's look at our first example. Here we have a simple method in which I am taking a parameter and an assignment and a for loop here. It's a very simple code. Now let's start to measure this code. So this line, the first line it's just a declaration, so the cost of this line is 0. Okay, now in the second line we are initializing and assigning a value to this variable named answer. So the cost of this variable, not the variable, but the cost of this line will be 1. Why? Because the number of time this line will run, this will take constant time, right? It's just a declaration and a assignment. So actually it's the assignment which is taking the time, because a memory is allocated for that variable. So the cost of this line will be 1. Now this is this interesting part. We have a for loop. In this for loop we have a declaration of a variable I. Then we are comparing. We have a comparison section here, in which we are comparing I with the n, and we are then the incrementation. So it's assignment and increment both at the same time. So now what the cost of this line? So first is simple. It's just an assignment of declaration and assignment of a variable. So it's the cost of this line is 1, because it will execute only once. When this method is called, this line will execute once, and this line will also execute once. Now we have comparison, and we have n. So the loop will run n number of times, right? If the value of n is 5, it will run 5 times. The value of n is 15 or 20, it will run 15 or 20 times. So I'll say n, okay, and then it will run n times n plus 1. I'll do plus 1. Now from where I am appending this this last one, it will run n times. It will compare actually n times, but it will not compare n times. The total number of comparison in this case will be n plus 1, because the last comparison will be of false. Suppose we have the value of n equals 5, right? But the total number of comparisons will be 6. How? Comparisons. Now it's correct, right? How? For the first, it's 0. The first comparison will start from 0. So we have 0, then 1, then 2, then 3, then 4, then 5, right? So starting from 0, we have 6 comparisons. This is 1, then 2, then 3, then 4, then 5, and then 6. When the value of I is 5, then it will return false, and then then the loop will break, right? So we have 6 comparisons. And I++ will take 2n. Why 2n? Because it's not only assignment, it's also addition. It's addition and assignment. So it is something like I equals to I plus I equals to I plus 1, right? So this is the cost of this line for the for loop. Now what is the cost of this line? This will be 2n. Why? Because we have a multiplication operation, it will run n times, right? And we also have assignment. So this line will loop n times, and there are two operations being performed, first in multiplication and then assignment. So we have 2n, and this is just a bracket, so it's 0, and return will not be taken as a cost, it's just returning the value. So now what's the total cost of this this method is 1 plus n plus 1 plus 2n plus 2n. So it's equal to 4n plus n plus 2, right? I've added this 2n, so it's become 4, then single n, and then 2. So the cost of this method, or you can say the complexity, is equals to 4n plus n plus 2. So the actual, we can say complexity is equals to big O of n, right? So it's actually 5n. Sorry, it's not 5, because I need to add this n also, so it has become 5n plus 2, right? So 5n plus 2. So the complexity of this code is 5n plus 2, and I'm saying is the complexity of the this code is n of big O of n. Why I'm not considering 2 and 5? Because these are constants, right? These are constant values, and when the value of n becomes larger, the effect of these two values will not be that much. How we will see in the later slides, I'll show you the graph in which I'll show how the constant values becomes irrelevant when you are measuring the cost of the code, right? Okay, so the cost of this method is big O of n. Now let's see some other examples. Now we have the second code, the second example. So this line, let's say this line is the two assignments. They are simply two assignments. The cost of this line is 2. Code and cost. Okay, so what's the cost of this line? We have just did that. So the cost of this line is simply this one. Let's copy this and paste it here, right? First is for assignment, and then the number of time it will run, and the third is plus and assignment. Okay, we have another loop within this loop, so we have two loops here, right? So what's the cost of this line? The cost of this line is n multiplied by, right? So what I am doing is, this will run, the inner loop will run n number of times. On every value of outer loop, this will run n number of times, right? So if the value is of this n, the upper n, the value of n is 5. For the first time, the inner loop will run 5 times, right? Let's okay, the value of n is 5. So I'll say parent loop. Okay, if the n value of parent loop is 1, the child loop will run 5 times, right? when the value of parent loop becomes 2, the loop will again run for 5 times, and this is how it will keep on going. Okay, so on every iteration of upper loop, the inner loop will run n times. So we have we will just copy this here, right? So this loop will run n times. On every iteration, this loop will run n times. And what will be, how many times this will run? This will run n into n times. Okay. Now it's 0, it's 0. So now what's the code? What's the cost of this? It's okay, yeah, it's 3n and plus n, 3n plus 2 plus it's n plus n square plus n by n square. This n will be multiplied by this one, right? Okay, then n is just a simple multiplication, nothing big. Okay, again n, because this n is multiplying with this one, and 2n square plus 2n square. Okay, plus n square, n square. Okay, so okay, now clear it. And what's the final cost of this method became? It's equal to this n plus this n is 4n plus this n. Let's take the highest order term first. 2n square plus 2 is 3n square plus 1 is 4n square. So we have I don't know why it's all happening today. Okay, we have 4n square plus 3n plus n is 4n plus n is 5n, 5n plus 2 and that's 2. So the cost of this method or this code is 4n square plus 5n plus 2. Okay, so I will say, or I can say, that the cost of the complexity of this code is equals to n square, right? As I told you that we take the highest order term into consideration, because when n gets large, or you can say n gets very large, the effectiveness of other values, these constant values, the 5 this 2 and n is not constant, but all the lowest order terms and the constant values, they become ineffective, or they are not considerable. How and why I'm saying this, I'll show you that. Okay, so we take the highest order term into consideration, and we will say that okay, the complexity of this code is this. So in this case, the complexity of this code is n square, right? Okay, so each basic operation in the code counts for 1, as we did all the basic operations like simple assignments, they all are 1. Okay, so we have 4 here, sorry, because I forgot to add this 2, so it will be 4. On here also let me add 2 here, 2 plus, right? Okay, now it's good.